Good morning, or good afternoon now. Welcome to the 29th annual exhibit of hydrogen fuel cells. I'm going to shorten my introduction. We all know we need hydrogen, and we need lots of it. And there's really big challenges out there for large-scale hydrogen production with renewable energies in particular. We don't want the gray hydrogen, not even the blue hydrogen. We need green hydrogen. And to tell us how to get it, we're going to be talking with Dr. Thomas Kattenstein, who is in the Competence Center H2 of HydroHub. Welcome, Dr. Kattenstein.
Yeah, thank you. Thank you for the kind introduction and welcome to my presentation. As you heard, my name is Thomas Kattenstein. I'm working for the company which is called EE Energy Engineers. We are located in Gelsenkirchen in the Ruhr area in Germany, and we are a daughter of the TÜV Nord company. Here you can see what our topics are very briefly, just to inform you what we are doing. I'm heading the competence center called Hydrogen, but we are working in general on the topics of energy, which you can see here, which is the renewable, which is energy infrastructure, which is the mobility. But of course, one major activity is hydrogen, and here we are working from the planning to the design, to the engineering, to the implementation of hydrogen facilities, be it electrolyzers, be it hydrogen stations, be it the conversion of fleets from fuel cell buses, and so on. So if you need any support with regard to hydrogen, we are the company of your choice, hopefully. In addition, we are part of the TÜV Nord group, which I mentioned before, and the TÜV Nord group has established now for a certain time the so-called HydroHub. The HydroHub connects all the activities with regard to hydrogen in the TÜV Nord group. So in addition to the topics that we are doing, we have a concrete engineering capability, we have an implementation capability, we have EPC, so procurement and construction capability, all within the TÜV Nord group. And if you're interested to hear more about that, please visit us here in this hall, booth 25, just that way, 50 meters in that direction. It is the HydroHub. But coming now to the topic of another slide for the introduction. I would like to mention that we are also working for the NRW North Rhine-Westphalian state government. We support the new energy agency, which is called NRW Energy for Climate. And here we're working especially on the topic of fuel cell mobility. And you can see it from the slide. We are supporting a project to implement 1,000 fuel cell buses in our state of 500 fuel cell trucks. If you're interested to take part in these projects, please ask me or visit the colleagues from NRW Energy for Climate, same hall, booth BO3, 100 meters in that direction. Okay, the topic for today is electrolyzer technology. And of course, we need, in the end, green hydrogen. That's for sure the final objective. And you can see from that slide, the key component is, of course, the electrolyzer, which you can see on the left-hand side. The electrolyzer produces hydrogen out of water, of course. It splits water with electricity, and we have, in the end, as output, hydrogen on the one hand side, but also oxygen and also heat, which could be used for heating purposes. And with that, hydrogen can work on an emission-free energy supply for the electricity sector, of course, but in addition to industry, mobility, and also heat. So that's the key approach, of course. And to go into more details, what is needed in order to implement electrolyzer technology? Of course, we need green energy. And green energy means we need PV farms or wind farms, or in some cases, of course, also grid connection is okay. Here you can work with PPAs, so with power purchase agreements, in order to safeguard your supply with green energy. We need the electrolyzer itself. We need additional components like H2 drying, like control systems. You can choose between four types of electrolyzer. I would say most common are today the PEM electrolyzer and the alkaline electrolyzer, the AEM, so the anion exchange membrane, and the SOEC are in the development phase. And to have a complete system, you need in addition a compressor, a storage, trailer system, or a pipeline connection in order to transport the produced hydrogen to the consumer. From our point of view, the technology readiness is very good. The technology is mature. You can see here in the exhibition a lot of electrolyzer producers that are already offering systems. We see performance rates for single modules from 2.4 kilowatt, which is the system of Enapter, of course, to 20 megawatt, which is, for example, the system of ThyssenKrupp Nucera. And with that, you can create your own electrolyzer system in the power range, I would guess, between 1 megawatt and 500 megawatt. What is about the efficiency? The efficiency is about 60 to 70%. That means you need as input about 55 kilowatt hours electrical energy to produce 1 kilogram of hydrogen. At the same time, you produce 8 kilograms of oxygen, and you can use the exhaust heat on the range of 50 to 60 degrees centigrade, and this is about 20% of the total capacity of the electrolyzer. In addition, you need, of course, water, around about 14 liters per kilogram. So 4.5 liters are so-called retentate. That means wastewater that is not used in the process. Required space, you can choose between container-based solutions. I would guess this is in the range to 10 megawatt electrolyzer systems. If you go beyond, you need your custom-made solutions with housings and so on. Unfortunately, today the times for planning and construction are rather long. We expect times today about 2 years. So from the first conception to the implementation to the start of operation, you have to calculate 2 years for the overall process. And of course, in the end, you have to use it. And again, the sectors which I mentioned, mobility, industry, energy, and residential use are the options that you can use for your electrolyzer system. What are the infrastructure and location requirements that you have to fulfill in order to start your electrolyzer project? Of course, you need to clarify the ownership of the area where you would like to deploy your electrolyzer. That's of course for sure. You need a sufficient size, you need the electricity connection, and you need a water supply connection, of course. In addition, you need the connection to the wastewater system, and ideally, you have also a customer for the heat, so you need a connection to the district heating system, for example. Also, you need, of course, a road connection. Maybe you would like to work with traders so that you have to transport the hydrogen in a lorry. The lorry has to come and depart from the spot, of course. So road connection is as well necessary. And then you need the consumers, which I mentioned before, for the hydrogen, in the ideal way also for the oxygen. This could be a wastewater treatment plant. And in order to have a complete system, it is useful to work also in a regional network, so that you have maybe other partners in your area that are interested in hydrogen, maybe as a customer, maybe as a supplier. And in the end, you need also funding. Today, you need still funding. And if funding opportunities are available in your area, in your state, or in your country, then that is, of course, good for the economic value. Permission and implementation is a very big topic. We cannot go through it completely in that short presentation. Again, here are shown the 2 years' time from the first phase to the final implementation, to the final operation. We consider the feasibility study is necessary. We need a basic engineering for that, and we need the preparation for documents, for the permission for the authorities, and that takes at least 6 months, maybe 12 months. Then you have to calculate the delivery times of the components. Could be 12 months or more. The permission process is about 3 to 9 months totally. And after that, you have the phase, of course, of construction. And if you summarize that, you come to a duration of about 2 years in total. What about the costs? Of course, you have to calculate the capex, so the investment costs for the electrolyzer. It's the most important part here, but also you have to spend capex for planning process, for the permission, for the construction, and also for the connection on site. If you need new power connection, if you need a new water connection, for example, then you have to invest here as well. For the OPEX, the operation costs, the most important factor is, of course, the electricity price. This is the most important, which we'll see on the next slide. But also we need, of course, some rent costs for the ground, for example. Maintenance is important, and also insurance. On the other hand side, we have, of course, some revenues from the hydrogen. So the hydrogen itself could be sold to the customers. And here it's important that the mobility market, the transport market, is able to pay more money than the industrial customers. For that reason, for today, it is good to supply a fleet of buses or fleet of trucks. This is most economic approach. Also, you can make money with the certificates, with the hydrogen certificates. Oil companies need to fulfill the emission reduction system, and they are, if they cannot do it on their own, they need to buy additional certificates. An operator of an electrolyzer could sell these certificates and make money out of that. And of course, you can have some revenues if you sell the heat and if you sell the oxygen. Here we have an example of a calculation of the levelized cost of hydrogen, LCOH. This is a rough calculation only, but it says, as you can see, the most important share of the costs, which are here calculated in total to about 10 euros per kilogram. The most important part here are the electricity costs, which are calculated here with 7 euros per kilogram. And the electricity price here is 126 euro per megawatt hour. In addition, you have to calculate the capex for the system itself and also for the installation. It's about 2 euros per kilogram and some operational costs, so that you end up with the 10, which I already mentioned before. If the electricity price is less than the 126, for example, yes, I already mentioned you can have subsidies, of course, you can have the sale, and with that you can decrease the LCOH to an amount that is interesting for a market like mobility and industry. So if you have a lower electricity price, for example, 100 euro per megawatt, which is a red dot, or 60 euro per megawatt, which is a green dot, then you come down, of course, with the LCOH, with the levelized cost of hydrogen. Then you are at 8 or 6 euros, which is much more interesting, of course, for your customers, and 6 euros per kilogram is already interesting for customers which are operating fleets like fuel cell buses. Subsidies. I showed you the figures of economy. We need, of course, still subsidies. The good point is subsidies are available, at least here in Germany. For the electrolyzer CAPEX, we have a funding program of the National Innovation Program. Here you can receive 45% of the investment costs. But the condition is, of course, you have to use 100% renewable energy, and you have to use the hydrogen 100% in the mobility sector. A call is open, still open. It's open until the end of this month and until the end of April. And if you're interested, please try to get your funding. In addition, I mentioned it already before, you can make money out of the selling of the certificates, which is about 5 euros per kilogram. And in the future, there will also be a funding for industrial consumers, which are the climate protection contract program, Klimaschutzverträge in German, and we expect that funding during the next months. Also, some federal states offer funding. Our federal state in North Rhine-Westphalia offers an additional funding, again for the capex of an electrolyzer for a hydrogen refueling station, again 45%. The difference is, in the NIP, it is for public stations. In our state, it's for non-public stations. And also, there's a funding available for electrolyzers used in stationary applications for residential areas, for small industries, for example, but this is limited to only 110,000 euro. So my last slide is a conclusion. We believe that the regional hydrogen production makes sense because it enables a local value creation and also grid balancing. You can use your domestic sources. You can install new renewable energies like wind and PV, but you can also make use of existing plants that are no longer running in the feed-in tariff law. And of course, you can start already now with hydrogen utilization. You have not to wait until a pipeline is there, until the European hydrogen backbone is there. So start your own activities in your region and try to implement also partners of your area. So final word, waiting is not an option. You should start now. At least you should think about starting now. And if you need help, of course, we are here, Energy Engineers, and the TÜV Nord is willing to help you with regard to your projects. Thank you very much.
Thank you. Where can they find you to discuss this further, your booth?
It's B25.
B25. Okay. Dr. Kattenstein, thank you very much for this wonderful introduction on the financial side also of launching large-scale electrolyzers. Very impressive.
You're welcome.